Good morning, ladies. Let's finish the last part of energy from chemicals. Okay, so take a look at these examples of common exothermic and endothermic processes. I'm going to highlight some that are more relevant for you. Okay, so for the exothermic processes, you need to know combustion. This is whenever a substance reacts with oxygen. Respiration, which is the opposite of photosynthesis. I'll talk a little bit about that in a while. Okay, neutralization, which is something that you learned under acids and bases. Okay, displacement reaction of metals, you learned this last year under metals. Acid metal reaction, okay, we learned this in acids and bases as well as metals. Addition of group 1 metals to water, this would be your topic of periodic table, okay, as well as metals. Haber process, we're going to learn that soon after we are finished with rate of reactions. Okay, you can ignore number 9. Then you have your electric cell, which you learned under simple cells, right? Chemical energy is converted to electrical energy in this case. Okay, something similar would be your hydrogen-oxygen fuel cell. And for the physical processes, condensation and freezing. For the endothermic processes, you do have to know, for example, thermal decomposition of metal carbonates is endothermic. Photosynthesis, right, which converts carbon dioxide and water to glucose and oxygen. Okay, so actually just now I mentioned that respiration, right, is the opposite of photosynthesis. So during respiration, what happens is that glucose, C6H12O6, reacts with oxygen to form carbon dioxide and water. All right, so it might be good for you to remember that photosynthesis is endothermic and respiration, which is the opposite, would be exothermic. Okay, we learned electrolysis. Electrolysis is endothermic, as well as two physical processes, melting and boiling. Okay, so for this physical processes, some students find it easier to remember melting and boiling as endothermic because you learned in kinetic particle theory last year, right, that in order to overcome attractive forces during melting and boiling, energy has to be absorbed by the particles. So energy is required to overcome attractive forces between the particles for it to melt or to boil. So this is something you learned. Therefore, for condensation and freezing, which would be the opposite processes, then they will be exothermic in nature. Okay, the next part I'll just go through very quickly because we will be looking at combustion reactions under organic chem a lot more in detail. Okay, but just to let you know what you need to know for this particular topic. All right, number 1, what are fuels? Okay, those are substances that can burn easily in air to give out energy, right? So it's not just heat energy. And some examples here of common fuels that we use. Okay, then you do have to know a little bit about fossil fuels, how they are formed, all right, and why is it that we have to conserve these resources which are non-renewable. Okay, so we will talk a little bit more detail about this in organic chem. Okay, then other things that you would have learned before: complete combustion of fuels, right? For example, coal, which contains carbon, right, will produce carbon dioxide. Okay, and if your fuel contains hydrogen, you also get water as a product, right? So complete combustion occurs when there is sufficient oxygen present. Okay, now if there is incomplete combustion, then that means that oxygen gas is insufficient, okay, and you may also get other products like carbon in the form of soot and carbon monoxide, which is a poisonous gas. Okay, we mentioned just now that combustion is exothermic. This is something you must remember. Number 2, how do you know that a substance is a good fuel? Okay, not everything that burns can be a fuel. So when you're selecting a fuel, you must remember the following points. Number 1, does it release a lot of energy when burnt? Number 2, is it safe to use? Is it convenient to store? Okay, so for example, if you compare coal, which is a solid, versus hydrogen, which is a gas, RTP. All right, coal, which is in a solid state, is more convenient to store because you can store it as it is. But hydrogen has to be liquefied, right, in order to be stored. So it does cost extra to do that. Right? We don't store hydrogen as a gas in the gaseous state. We have to store it in the liquid state. So in order to liquefy it, money has to be used. Okay. Number 3, is it reasonably cheap and readily available? So for example, coal is still more readily available as compared to hydrogen. All right. And the last one, it doesn't produce smoke, any unpleasant gases or poisonous gases. So in this case, hydrogen would be a better choice because remember it only produces water, right, upon combustion, or if you were to use it in a fuel cell. But if you use fossil fuels, it may produce things like sulfur dioxide, oxides of nitrogen. Right, so we will learn more about air pollutants again in another topic. Okay, so you learned about hydrogen as a fuel under fuel cells last year, so I'll leave you to read the rest of the notes on your own. Okay. Now these are the multiple choice questions that you can try. Okay, I will do a few with you. Let's look at question number 1. Which of the following reactions is endothermic? Okay, so for this question, you have to be able to identify that option A. Okay, what does 2H mean? 2H actually refers to 2 individual unbonded hydrogen atoms. All right, then H2 is the hydrogen molecule. Okay, so in this case, you can see that bond formation is taking place, and so this is exothermic. Option B, you had to recognize this as combustion, right? Something reacting with oxygen. So this is exo as well. You can ignore option C. Option D, you had to recognize that this is photosynthesis, where carbon dioxide and water are converted to glucose and oxygen. Photosynthesis is endo. The last one, C4H10 combines with oxygen, so this is again combustion, which is exothermic. So the answer is D. Let's look at question number 9. Electrical energy is produced by a simple cell as a result of, right? So for this one, you need to recall how a simple cell works. Okay, so the main idea is you have 2 different metals of different reactivity. Okay, and the more reactive metal loses electrons more readily. All right. So as a result, the more reactive metal is the one that will give up the electrons that travel through the wire. So that constitutes an electrical current. Let's look at question 19. All right, you're given the equation for respiration. So you can see glucose reacting with oxygen to form water and carbon dioxide. And you're told that the reaction is exothermic. Okay, so what can be deduced from the equation? Option A, delta H for photosynthesis is positive 2830 kilojoules per mole. This is correct, right? Because we know that photosynthesis is the opposite of respiration, and therefore the delta H would be positive, right? Energy from sunlight is needed for this reaction. That's not true because energy from sunlight is needed for photosynthesis and not for respiration. Okay, respiration is carried out by animals only. That's not true, right? Plants can also respire. The last option, the equation shows a reaction between 1 volume of glucose and 6 volumes of oxygen to produce 6 volumes of carbon dioxide and 6 volumes of water. Now, for this particular option, they're actually testing you on your understanding of Avogadro's gas law, right, where 1 mole of any gas will always occupy 24 dm cubed at RTP. Okay, but you have to notice that, ladies, glucose is a solid. Right, so being a solid, the Avogadro's gas law is not going to apply to glucose. Okay, so the correct answer is A.